So good morning, welcome. My name is Jean-Philippe Thiran. I'm the director of the signal processing lab here, and I will be your teacher for this course on image analysis and pattern recognition. Very warm welcome. I'm happy to see so many of you here. This year it will be a record number of students in this class, so sorry for the discomfort. I hope you are well installed. Roughly speaking, you are now probably 70 in this room. You should be 120 attending this course. So it will fit or not. We'll see. So, but very happy to have so many of you. And this year we are very happy because we have a very diverse audience. You are from many different sections and obviously with different backgrounds and skills. So my challenge will be to teach something to you which will be useful for all of you, which is a kind of a challenge, right? So very happy to have you here. So I introduced myself. I will not ask you to introduce yourself, each of you, but at least just to let you know the diversity that we have. I will just have a quick look at the registrations. And normally we should have, is it a majority? Yes. No, it's not a majority. We should have a good number of electrical engineers. Can you please show me who you are? Okay, welcome guys. Welcome at home. So, yeah. Then we should have a small number of data science people. Yeah, welcome. Good to see you here. Happy, really. Bioengineers. Yeah. Should have a large number of robotics guys. Yeah, majority, obviously. Ingénierie des sciences du vivant. It's not bioengineering, right? Okay, welcome. And that's it. Any other people? From? Hello? Which section? Forensic science. Ah, yes, I remember. Forensic science. So UNIL, right? Welcome. Happy to have you here. Any other? So obviously you are not all here. And the reason might be that there are conflict of schedule. Who has a conflict of schedule has to choose this course or attending another that is also in your agenda. Yes. And those who are not here probably all of them have a conflict, obviously, or they are sleeping, I don't know, but whatever. So this is why we have a special organization this year, and it was already the case last year to a smaller extent. As you have seen, I'm recording the lecture. So you will have the recording, just a simple recording. It's not a MOOC. It's just the recording of what I'm saying. It's recorded, and you will have it live, not live. You have the movie in Moodle by the end of the weekend, as soon as I find time to process it. So you will have it, and you will have all the lectures like that recorded. Actually, except this lecture, which I record every year, all the others have already been recorded. So they will be made available before or after the lecture. They are actually already in YouTube if you want to check. So basically, make your schedule the best you want, how you want. If you cannot attend, too bad, but still, the lectures will be recorded, okay? So do not stress too much. But I will come back to the schedule of the course because there are a few elements that you will have to attend and that you have to make your mind how to do that. Don't worry, you can pass. Okay, so let me give you first an introduction, and then after that introduction, we will have the first lecture. As you will see in the schedule, we will have full mornings of lectures. Well, full. We start at 9:15, as you can see. It's not 8:15. But still, I will give a full lecture this morning and a few others all over the semester. But then, in the middle, you will have different labs and things like that. I will give you the details of that. What are we going to see in this course? This is supposed to be an introductory course to image analysis and pattern recognition. So basically, I will see what are the big blocks of methods that you have to know to understand an image analysis problem, right? So basically we will learn how to recognize the content of images. Pattern recognition is to recognize the content of images. And, well, analysis is also to extract objects. You will see what we are talking about. So basically, we will try to learn together the big blocks to allow you to really automatically or semi-automatically extract information and recognize shapes in images. Come on, okay. And we are all able to do that. You are reading the slides, you are looking at me now, so you are able to recognize a number of, a large variety of elements in the image that you capture with your eyes. how can we teach a machine to do that? That's really what we are trying to do in this course. Again, this will be the basics. That means that there are a huge variety of methods to do image analysis, from very simple, that I will teach at the beginning, to very advanced machine learning-based techniques that we will see a little bit at the end. So we will cover the whole spectrum, but we will not go into details of all of them. I mean, it would take your life, basically, to go through all the state of the art. So basically, we will see the blocks. But those blocks will be enough for you to take a scientific paper and understand the content, because the structure always remains the same. The difference is in the method, in how they work. But the structure of how to analyze an image is what I want to teach. And the big concepts is what I want to teach, right? At any point, if you have questions, even if you are a lot in this room, if you have questions, please do not hesitate. You will see the schedule is not that stressed. We have time to discuss. So basically, do ask your questions. If I'm not clear, please ask me to repeat. If you don't understand my poor English, please ask me to repeat. So do not hesitate. We have to do that. Even if we are a large class, I always do that, and I would like to keep doing that with you. Okay? Clear? Good. So, what are we going to do? Well, we are going to do something like that. What is pattern recognition? Well, it can be optical character recognition. Optical character recognition is just an example, but it's how to teach a machine to recognize written language. Word recognition, sentence recognition, meaning recognition. And I always take this picture because I received it a while ago, as you can see. Well, you can recognize what I received, right? In 1 second, you recognize that there was a baby that was born at some time. The baby was born, now he's 19 years old already, so it's not a baby anymore. But at that time, I received that. And the baby was born on that day, and he had a certain weight. And obviously, he has a brother called Valentin. And there are a few things telling me that, yes, we are talking about babies. This is what you do in a fraction of a second. Now, just try to see how a machine could recognize just the meaning that I said, that there is a baby that was born, there is another guy, which is his brother, and we are talking about babies. Just think how you would teach a machine. The input that you will get is an image with pixels, black and white. And I will keep calling that stupid pixels. You receive a binary matrix, black and white points. Just try to imagine the complexity of the methods that we have to do to recognize just what I said, which is so simple. You will have to recognize that there are things that are less relevant and things that are more relevant. You will see that there is a forename here. Well, what is it? I don't know. Ah, yes, it's the name of the baby. Fine. So, complexity. But at the end, we'll try to see the big blocks to do that, and not only that, obviously. So, you will find pattern recognition questions in many, many domains. You will find that in speech recognition. Doing speech recognition, automatic speech recognition, is really taking a wave, a pressure wave that you receive on a microphone, convert it in electrical signals, that's easy, and then run something that will analyze the content. So basically extract information. We will not do speech recognition in this course, but the concept is basically the same. There are a lot of industrial applications. You want to do inspection, you want to do quality control. And in our domain, we collaborate a lot with industries. My lab, we collaborate a lot with industry to do really image analysis in an industrial context. This is a very simple example of recognizing defects in an industrial production. You have a chain of production. This is welding of some metallic pieces. And you have at some point to do a quality check whether the job has been done correctly or not. Well, you use image analysis. We have done that for a large variety of problems in collaborations with small and big industries, ranging from Nespresso capsules to see if they are well done, to measurements of things that you will see later on the road, and things like that. So there is a large variety of applications. You will also find applications in biology. A lot of biology now relies on high throughput imaging. You have a large number of samples. It's called high throughput systems. You have a lot of samples, you know, the tissue samples on the glass, on a piece of glass, and you want to do screening. You want to diagnose patients from a large number of samples. Obviously, you need computers. Obviously, you need image analysis. How to do that? Well, we'll see. Then other examples. Autonomous vehicles. Yeah, of course. Of course, if you want a car to drive, it has to see what you have on the road, plus other signals, of course, GPS and so on. But you have to. Simple applications like security. This is something we have been working on quite a long time ago, which is now a product on the market. Recognizing fires by video. Of course, you would say, okay, recognizing fires, I don't have a smoke detector here, strange. I should. In a room like this one, you should have a smoke detector. But the problem is that there are places where when the smoke will reach the detector, it's far too late, right? So that's an example where videos could help. Or in places where you have no ceiling. In open spaces, you have no ceiling, so no detector on the ceiling. So video detection. Things like that. And again, coming back to the medical domain, you have the whole domain of medical imaging, where you want to use image analysis methods to help the clinicians defining whether this patient has a multiple sclerosis or not. Multiple sclerosis, sclérose en plaques in French. And whether this patient has multiple sclerosis or not. And count the number of lesions that you see in the brain. This is a very tedious work and very prone to mistakes if you do it by your eyes, by hand. So computers can help. This is just a way to motivate what we want to say and to hopefully convince you to stay in this classroom, although it's very loaded. So that's basically what we will do. And what we will do is really see the big blocks from the basic methods to the most advanced in general. And you will have practical works. You will try and you will practice that as well. What I consider as an image processing system or a pattern recognition is actually a system in the mathematical sense of it. You have an input, you have an output. The input is the stupid pixels. Really, they are stupid because they are just an array of things. But you are not stupid, so you are able to design a method that will extract information from those stupid pixels. But the raw data are really, really like simple and nothing fancy. It's a matrix of values. So we receive those raw data from the sensors, imaging, 3D imaging, 1D signal, 1D biosignal, 1D speech, whatever. And we want to give, at the end, a decision. That's really what we will do. And now I will show you a drawing, which I will show you at the very beginning of each of the lectures that we will have together this semester, because this is what you have to keep in mind when you think how to solve a pattern recognition and image analysis problem. This is just the very schematic view of the system I was mentioning just before. Everything starts one day or another with a sensor. Sensors capture the reality. It can be a CMOS sensor of your camera, it can be a microphone, it can be whatever. But after that, you will have to do a series of steps to finally come to a decision. And those steps are basically those three big steps. And those three big steps are the three big chapters of this course. And in each of the systems that you can imagine, you will have those three steps to be handled one way or another. It can be very explicit, as we will see in this course. It can be a little bit hidden in those very nice and fancy deep networks, for instance, that you are all familiar with, I guess. But still, what those systems do is also going through those different steps. So those steps are the building blocks when you do image analysis. And depending on the problem, you will have to choose the right method for segmentation. I will describe that. The right method for description, the right method for classification. And if you do that, at the end of the classification, you will give, to the next step, a decision. And so we will do that. We will start from the sensors. We will not see the sensors here. There are many other courses where you will study the sensors. This is about electrical engineering. This is about metrology. This is about microtechniques. This is about that. We'll not do that here. But what we receive here at the entrance is the raw data, the stupid pixels, if you are talking about images. And the first thing that we will have to do is to take those stupid pixels and, via segmentation methods, to come up here with what we will call objects. An object is a group of pixels. I will redefine that. which makes some sense for reapplication. And that is what we will do first. We are going to do image processing to do that, the segmentation. I'm looking at the picture that I have in front of me, and I see a lot of faces watching me. That's fine. So I'm doing segmentation. I see your different objects. You are objects, guys. Sorry. And then I will say, okay, I have those objects. Now I want to describe them. I want to extract features that will describe the content of those objects. Do I see eyes or not? If I see eyes, probably it's a face. If I don't see eyes, whether you're sleeping or it's an empty chair, right? So, from the objects, all the objects, I will describe them. We'll talk about geometry. We'll talk about features. And now I will be here with just a set of features, a vector of features. No pixels anymore, no objects anymore, just features. Many, but features. And those features will be the entrance, the input to a classifier. And that's where machine learning, artificial intelligence comes. And only there. Okay, in some methods, it percolates to the previous levels as well. We will see that. But if you want to make it very simple, here you have features, and then you build a classifier that will give you, not features, just a decision, or a score, or a value. Well, something that you can use as the output of your chain for, I don't know, commanding a robot, or classifying your image in a given class. And I will show you that each time, because it's a very simple but systematic way to approach an image analysis problem. Okay? So, practical points for this lecture, for this course. We have officially 2 + 2. But as you see, I will have some of the days dedicated to lectures, and others I will show you to practical labs. So we will see those main methods along the 3 main blocks: segmentation, description, classification. This will be the oral lectures. And then you will have a series of labs. Each one, well, 1 lab on each of the 3 chapters. So 3 blocks, 3 labs. They will be real examples, well, quite simple because you only have a limited number of time to solve it, but basically addressing those 3 different chapters. And in average, you will have 1 week, so basically it will be the Friday morning, there will be no lecture, and you will be free to go to the lab. There will be teaching assistants to help you doing that, but you are free to do that when you want, of course. I will come back to the details in a moment. And then at the end, we will have a few weeks of what I call the special project, which is actually a mini project that you will have to do, which is really about using that on a really more realistic problem. And I will, again, tell you more about that. Keep in mind the evaluation of this course. There will be no exam during the June session. No exam. Okay? So, good or bad, at least at that time, you will be done for this course. But you will have three contributions to the mark that you will get. One is the reports on the lab. And if you count the number of hours that you will spend, it's about 25%. So after each lab, you will have to upload on Moodle a small PDF, and not 20 pages, 5 pages or so, with your answers to the lab. And this will be 25% of your mark. Then we will have individual interviews. You want to call it exams? I'm fine. I call it interviews. We will meet individually, each of you. Well, I was not really prepared to have so many of you in these lectures, so probably we'll have the opportunity only to meet once for 15 minutes. With 120 students, I cannot really do more. And in 15 minutes, I will ask you basically 2 questions. You will basically pick randomly 2 questions covering the whole course. You don't have to learn by heart. You will have the possibility to have the material in front of you, your computer if you wish, whatever. And we will discuss. But 15 minutes is very short. So if you have not prepared that interview, no way. If you say, oh yes, I know in which chapter, let me read it again and I will explain you in 5 minutes, you're done, okay? So you will have to prepare that interview, obviously, like another exam. But it will be sharp, to the point, and really seeing whether you understood the content of the course. There will be no fancy, complicated question. It's really what do you know about image segmentation by this method? And then you take your notes, but obviously you have to be prepared. Okay? So interviews. And then the last weeks, as I said, we'll have this more practical mini project, which amounts for 35%. I will come with more details about the schedule of the interviews when I will know exactly how many you are, because you know you have, 2 weeks or so to decide whether you want to stay or to leave. Don't hesitate to stay. But when I will know, I will be able to say whether we will meet twice or just once. In theory, I would prefer to have 2 interviews. It's also more fair for you. But in practice, we do what we can. Okay, here is the schedule. This is today, lecture. And we want to move on. We want to advance. So basically, we'll have 4 lectures in a row. So this will be the main block of the course, actually. You see, it's 3 hours per week, so it goes quickly. So we will basically cover already a large chapter, which is basically that chapter of segmentation, at the beginning of the semester. Keep in mind, each time at 9:15, I don't want to teach 4 hours in a row, and you don't want to follow a course 4 hours in a row, right? So 3 is already good. I think you will see. We'll have breaks, by the way. And so those four weeks lectures here, and they will be recorded. Then you will have a week, but that's not the right schedule, I'm sorry. I changed it yesterday, and I forgot to update my slides. But on Moodle, it's correct. So let's go to Moodle. But it's almost correct. The one that you have in Moodle is correct. Up. Sorry for that. I will update the slides. Here we go. And the schedule doesn't appear. Super cool. Super cool. Okay, let's do it differently. I will update that again, obviously. I have it somewhere else. Do you see it in Moodle yourself? No, probably. It's not a problem. Here is it. Okay, that's the real one. And I will update that on Moodle and in the slides. Sorry. So we will have 3 lectures, actually. Because that's the 3 lectures for the first chapter on segmentation. And then you will have 2 weeks for the first lab. The first lab is a little bit bigger than the others, not that much. So with 2 weeks, you will have plenty of time to do it. One word about the labs. You will have to solve a certain number of problems. For instance, for that lab 1 on image segmentation. What I expect, you will see the description of the labs are extremely small. Something like, here is a picture. What is the size of that object? Point. Number of pixels. And you will have to do what you want to extract the object and count the number of pixels. The more you try, the more points you will get. So you can do very simple methods and find the right solution. Well, there is no really right solution, but find the right solution with one method, but I will not be happy with that. If you try 2 or 3 variants, 2 or 3 methods, even if they fail, I will be more happy. And you see what I mean by being more happy. So the goal is really for you to try, to make your mind. We are in a domain where you learn with your fingers. You try. Image processing is a kind of an art. You have a library of tools, and you have to choose the right tool to solve the problem. And by trying different, you will make your mind on when to use which one. So that's basically what I expect from you for the labs, especially for this one where you have 2 weeks, which, frankly, is quite a lot. The reason is simply because I will be traveling on one of those days and I cannot teach. But frankly, there is content for 1 week. I'm recording, I should not say that, but anyway. Then you have 1 full lecture on description, 1 lab on description, 1 full lecture on classification, 1 lab on classification. And we have an Easter break somewhere. And then the 5 last weeks, we will do what I call the special project, which is basically a practical part where you will have a first lecture somewhere at the beginning to just instruct you to solve a real problem. And it will be fun. And we will do a kind of a mini contest You will work by groups, or I should say that, but you will work by groups and you will compete against the others. I like that. And it will be a practical work. It will be about machine learning, but based on what we will see. And each time you will work by groups. Depending on the number again, it might be by groups of 2 or 3. For the labs, the 1, 2, and 3 labs, it will be by groups of 2 for sure. For the mini projects, depending, because I want to have a quick oral presentation at the end, I might ask you to work by groups of 3 because of the number you are. I will tell you more, so don't form the groups yet, except for the labs, you can already think of the groups that you will want to have. I will update the schedule again, I'm sorry for that. Okay. Questions? So this is not the right schedule. Yes?
Just to make sure, so the interview is regarding the poster report.
The what?
The interview?
Well, the interviews, again, depending on how many I manage to do.
Yeah.
So if I take the schedule again, but the right one, normally I do the interviews during the labs. So in a normal year, in the good old times when I had only electrical engineers, so maximum 30 students, it was easy. I had plenty of time in each of the labs to see everybody. And I had sometimes even 3 interviews. Most of the time, 1 interview here and 1 interview here. Now with 120 students, I most probably cannot offer you 2 interviews. So it will be only 1, probably during the time where you prepare the special project. 15 minutes you come to me, we'll do a doodle or something to do that. And it will be indeed on the whole course. So basically there will be 2 questions. One on the first part, which is segmentation and feature extraction. And one on the classification, which is a bit more dense. So 2 questions on the two main parts of the course. If I manage to do 2 interviews, I promise I will do. It's just a question of feasibility, because it's much more convenient for everybody. Okay, this answers your question? Pardon, sorry, this answers your question? Yeah. Other questions? Yes, please. Please speak loud. Yes. Shit, is it? Is it? Shit. That's annoying because I will be away on the 19th, so I have to change my mind. Okay, good. Yeah. Okay, so you have 2. Okay. That's not that bad, right? Okay, then we have to change a little bit the schedule. Okay, I record that this is the Good Friday, as it is called, Vendredi Saint. And this is officially off, right? Shit. Okay. Shit. Okay. Bon. I have to update my schedule. Thanks for the comment. So you have really only 13 weeks this year. That's really limited. Okay, other questions? Yes?
How much programming and machine learning do you need to know ahead to be able to do that?
This is an introductory course, so I consider that you should not have any background there. But of course, about 50% of you have background in machine learning, and about 50% of you do not. So I will, of course, consider that you don't have, and if you have, that's not bad. But what I see is really not machine learning only. It's really image analysis. So you should, even if you have already other courses in machine learning, you should learn something here. Of course, the practical part at the end might be a bit simpler for you. In terms of programming, we work with Python. If you don't know Python, you will have the time, well, it will go slowly and you will learn it. We consider that you all should know Python, at the end of this course at least. Who doesn't know anything about Python? It's okay. So you will learn something interesting, I'm sure. And do not stress. We know. In the worst case, we can flip back to MATLAB. In the worst case. But I think you should do a little bit of Python in your studies, so it's not that bad. And you know, the teaching assistants will help you. Anyway. Who would say that they are not skilled in machine learning? What I mean is, you might have courses in machine learning, and let's say you might even have courses in parallel to this course, or before. Introduction to machine learning or things like that. who would not say that? Who would say he has no background in machine learning? A little bit also. Again, that's not a problem, but of course you will have to catch up a little bit faster than the others. Okay? But that's okay. There is no prerequisite for this course, at least. Okay? Okay, so let's continue with the end of my introduction. If you want to buy a book that will help you in this domain, I suggest you to buy this book. That is an old edition, but it has been revised regularly since then. It's an investment. I don't ask you to do it. I really don't ask you to do it. But if you have an interest in image processing, not machine learning, but image processing, this is a good book. This is a kind of a reference textbook in French for those of you who want to do that. Final practical stuff. Moodle. Moodle is online. Obviously, I don't know why the schedule doesn't appear, but I will fix that. You have the agenda, you have the slides, you have the description of the lab. That's where also you will have to upload your reports. You have the contacts, the TAs, and I don't think you need it, but if you need to register as a free student, free attendant, you have a key that you can use if needed, especially for the people from outside. One last word about the report that you will upload on Moodle. Where is it? For the labs. I told you the 3 labs, you will have to do that by groups of 2. But for me to be able to check your work, I need a report per person. It's just the same report that you have to upload twice. So each of you has to upload a report. But obviously, if you work by groups of 2, it can be twice the same report with the 2 names on each of them. I have no problem with that. But I want an upload per student. If I see a missing upload, I will not give a mark, even if you are part of the group that also uploaded the report for the other students. If I don't see an upload, I don't give you the mark. Simple. Because I don't want to start checking who is grouping with whom. Okay? So that is very clear, and this is recorded. So there is a proof that I said it. Okay, finally, and then I will have a first quick break. What time is it? No, not yet. Just a few more examples on the things that you might do if you do image processing. You might do medical imaging. You might want to work with images of patients and try to extract information from those images. Like this patient has a tumor, and the tumor displaced some of the big structures of the brain. Can you describe that to help a surgeon planning his surgery? This is a very real, concrete example. Do you want to do face image processing? Do you want to localize, to recognize, to track faces? We will see how to do that. Not in the details of face tracking, but the components of a pipeline to do that. As an example, you might want to do facial expression recognition. You don't see it because it's an infrared image, but you kind of see a face there, and at least you see the mask on it. And a system has been built to recognize, to track the face, to track the landmarks on the face, and recognize the expressions of that person. And this is something we have been developing for years in a very concrete context of the automotive industry, where the smart cars want to analyze the behavior of the guy who is supposed to drive. Drive or not. In the context of autonomous vehicles, at some point, it might be useful for the driver to take back the control of the car. And the tendency and the state of the art is really for the car to be able to estimate whether the driver is able to drive now. So you are in an autonomous mode, you don't drive, and suddenly the car is saying, oh, it becomes too complex for me, I want you to take the lead. I want you to drive. But the system has to know whether you're sleeping, you're talking, you're writing your emails, and wants to know what is your status. And so in that context, doing facial expression recognition is important. Another thing that we have done is stress detection. So basically, by the same system, detecting the level of stress of the driver to know whether he's able to take smart decisions or not. I'm not coming. Last example, this is I will just switch to that. This is a project that we have done where we have a startup company, actually, which tries to estimate the cleanliness of a city. Why? Well, basically to optimize the way the cleaners organize their tour in a city. When you clean a city, you have cleaners, cleaning machines, and most of the time they go at the same place on the same day every week, whether or not there are things to collect, whether or not there are dust on, well, there are things to collect like leaves, like cigarette bits and things like that. And so basically being able to map the cleanliness over time allows the cities to optimize and save a lot of money. And this is basically a machine learning technique that very, very accurately counts the cleanliness by a camera that is fixed on something that is moving. And you go once it can be the cleaning machine itself, it can be a car, it can be a bike, and you map the cleanliness of the city. You give an index of the cleanliness, and then you optimize your tour, the way you collect, the way you clean, and then you remeasure the cleanliness and you get an improvement in your cleanliness. And there are a lot of cities that are interested in that, also for marketing purposes. I want to say that my city is clean, but also for saving money. And we have founded a startup that is very successful. And that's my introduction.